बिस्मिल्लाहिर्रहमानिर्रहीम। तो आज क्वांटम मैकेनिक्स में जो हमारी क्लासेस है, जो इस क्लास में जो टॉपिक्स डिस्कस होंगे उसमें जो सिलेबस में है दैट इज रेडियल वेव फंक्शन, हाउ वी कैन रिप्रेजेंट इट ग्राफिकली। तो यू कैन सी हियर, सो द टॉपिक नंबर 1 इज द ग्राफिकल रिप्रेजेंटेशन ऑफ रेडियल वेव फंक्शन एंड देन ग्राफिकल रिप्रेजेंटेशन ऑफ एंगुलर वेव फंक्शन। यानी हमने अभी तब तक जो क्वांटम मैकेनिक्स में रेडियल वेव फंक्शन एंड एंगुलर वेव फंक्शन डिस्कस की थी लास्ट क्लास में, हाउ वी कैन रिप्रेजेंट दोज ग्राफिकली, नंबर 1। फिर सेकंड टॉपिक जो इसी के रिलेटेड है दैट इज रेडियल एंड एंगुलर नोड्स। तो इसमें हम बेसिक चीज है जो वो डिस्कस करेंगे। थोड़ा सा मैं पीछे जा रहा हूं। लास्ट क्लास में हमने ये डिस्कस किया था कि जो वेव फंक्शन है दैट इज बेसिकली इट हैज टू पार्ट्स। वन इज द रेडियल पार्ट, दैट इज द रेडियल वेव फंक्शन, एंड एंगुलर वेव फंक्शन। सो हमने ये बोला था कि रेडियल पार्ट इट गिव्स अस एक्चुअली द डिस्टेंस एट विच वी कैन फाइंड द इलेक्ट्रॉन्स from the nucleus, and this angular part gives us the concept of orientations. And where are those electrons oriented, in which direction they are oriented, or at what angle they are oriented. So this gives us the concept of atomic orbital. So this simply gives us the radius. ठीक। Now अब आज भी क्वेश्चन पे आ जाते हैं, रेडियल वेव फंक्शन, how we can represent this graphically. So graphical representation of रेडियल वेव फंक्शन। ठीक। नाउ उसमें आपकी जो सिलेबस में है, विल मूव थ्रू द सिलेबस। सिलेबस में यू हैव सम ऑर्बिटल्स गिवन, फॉर एग्जांपल 1s ऑर्बिटल, 2s ऑर्बिटल, देन वी हैव 2p ऑर्बिटल, देन वी हैव 3s ऑर्बिटल, 3p, and then we have 3d. So these are the various orbitals which are present in your syllabus, given in your syllabus. So we have to see a graphical representation of radial wave function in these orbitals. So radial wave function हमने ऐसे भी दिखाया था, r. So this was how we have shown the radial wave function in the last class. So let us see the graphical representation of a radial wave function. So graphical representation of radial wave function. A 1s orbital, we'll take 1s orbital. तो 1s orbital के लिए जो graphical representation है that is अगर उसका ग्राफ देख ले तो ग्राफ looks like this. So this y-axis, it is actually your radial wave function. Yeah, इसको psi r भी ले लेते हैं, so we'll keep it r. So this with x-axis means when you move away from the nucleus. So this is the point closer to the nucleus, or this is the nucleus. So when you move away from the nucleus, so let us keep it r distance in picometer. So this graphical representation, the variation of wave function with respect to distance from the nucleus, अगर आप ये ग्राफ प्लॉट करेंगे तो you'll see a graph comes like this. अब यहाँ क्वेश्चन है कि ये ग्राफ हमने कहाँ से लाया। जैसे मैंने पहले ही कहा, इन द क्वांटम मैकेनिक्स वो जो हमने श्रोडिंगर वेव इक्वेशन फॉर हाइड्रोजन एटम के लिए स्फेरिकल और एंगुलर कोऑर्डिनेट्स यूज किए थे लास्ट क्लास में, वहीं से सॉल्व करने के बाद we plot this versus this and then we'll get up this type of graph. So those we need not to worry about those equations, that they are complex equations. So basically यहाँ पे थोड़ा एक चीज डिस्कस करना चाहता हूँ. In case of a radial wave function, that it depends, radial wave function जो है that वहां से उन्हीं इक्वेशन से radial wave function actually depends on, it can be shown like this, that it depends on an exponential term that is E minus Z R divided by, इसको आप माइंड में रख सकते हो क्योंकि sometimes we get these type of questions. So basically the radial wave function which is obtained from the Schrodinger equation, that radial wave function depends on the exponential of minus Z R. The Z is the atomic number, R is the radial distance, A is basically called the Boho radius. So that Boho radius also sometimes the question comes in the exam. So we can remember this Boho radius also. So the Boho radius is a value equivalent to 0.529 angstrom per hydrogen atom. Means from the nucleus, if we talk about the nucleus से जो आपका the first energy level है, या electrons can be found at the minimum possible distance, where there's most possibility of finding the electrons from the nucleus. That's called basically the Bohr radius. And for hydrogen atom it is A0, that is equal to 0.529 angstrom. So the radial wave function depends on exponential of minus ZR. That means if you move away from the nucleus, the radial wave function decreases because it's the negative of that. So that's why 1SK case mein our graphical representation of plotting wave functions R comes like this. So that means you can clearly see that the radial wave function decrease. That means probability of finding the electron decrease. That means in case of 1s orbital, there's maximum possibility of finding electron closer to the nucleus. So usko main aise dikha sakte hain. If this is nucleus, so electrons can be found here closer to the nucleus. And if you move away from the nucleus, there's the chances of finding the electron density is almost not negligible. So this means the most maximum possible distance of finding the electrons closer to the nucleus. At the moment we move away from the nucleus, the electron density goes on decreasing. So this is for 1s orbital. Likely if we talk about the second case, that is 2s orbital. So 2s orbital, this is your radial wave function. This is with respect to the distance. So for 2s orbital you have this type of a case. So you have a decrease here, fine. This is the graph how it comes. It goes below this plus point. So you can see here the electron density decreases. So then it reaches to a point where there is zero electron density. But then again the electron density increases. So that means in this case a new concept comes into account, that is if you draw it here. This is nucleus. So electron density goes on decreasing. That means this region is high in the electron density. Now if you move away from the nucleus, then there comes a region where there is the electron density. Then after that electron density also increases. It's like this. So we can draw it like this. So you can draw it like this. अब यहाँ आप देख सकते हो closer to the nucleus we have each the electron density is rich. After that you can see this blank gap here. It means there is no electron density present. Then after that when you move further away from the nucleus, again we have electron density here. So that this point actually where we have the zero electron density here, that is this blank one, this one. This is basically called as the node. So this is the concept of the node in the quantum mechanics. That's why मेरा जो next topic था, that is the radial and angular nodes. So I will try to cover up these both parts. So this is called as the node. Okay? So that means in case of 2s orbital we have one node. So the number of nodes is basically given by n minus l minus 1. So the number of nodes is given by n minus l minus 1. Now for 2s orbital, n is 2. For s orbital, l is 0 minus 1. So that is 1. So the number of nodes is 1. So this is how the graphical representation of the wave function. Now we have the next one, that is 2p orbital. So 2p orbital, so 2p orbital, this is radial wave function. This is your r. So if you plot that 2p orbital like this. So यहाँ पे पहले electron density decrease as we move away from the nucleus, and then we have a node, then again the electron density is there, the negative direction, then we have a node, one more node is there, so then again in the positive. So we have two nodes here. So that means in case of 2p orbital, let us see, we can calculate using the formula n minus l minus 1. So this is 2, l is 1 minus 1, but 2p orbital l is 1, that is the azimuthal quantum number. So it becomes 2 minus, sorry, what has happened? So this is your 2p orbital, sorry, this is 3s orbital, 3s. So this is your 3s orbital. So for s orbital, this is 0, l is 0. So this is 3, n is 3, that is equal to 2. So the number of nodes are 2. So that means if we want to draw this, the paper, what do you mean by 2 nodes? We have nucleus here at the center. Then there is electron density which decreases with the distance. So it's like this. So electron density is there. And there's one node coming here. So we have electron density here again. And then size बड़ा हो रहा है इसका. Anyway, no problem. So just representation आप इसे ड्रॉ कर सकते हैं बाद में बुक पे. अब यहाँ पे देख लीजिए आप, ये आपका न्यूक्लियस हो गया सेंटर पे. न्यूक्लियस के आसपास देखिए देयर इज रिच इलेक्ट्रॉन डेंसिटी, ठीक. बट व्हेन यू मूव अवे फ्रॉम द न्यूक्लियस देन यू विल एंड अप विद अ नोड. सो जैसे आप न्यूक्लियस से बाहर जा रहे हैं, यू कैन सी द स्पेस हियर, दिस इज नोड नंबर 1. दैट मींस देयर इज नो इलेक्ट्रॉन डेंसिटी. अगर आप फर्दर चलेंगे फिर इससे आगे, देन यू कैन सी दिस पोर्शन, यू कैन सी हियर द इलेक्ट्रॉन डेंसिटी. Then when you move further, you have one more node here. That's why this is second node. So there are two nodes here, this one and this electron density. So that means in case of 3s orbital, the electron density varies in this fashion. That is, we have rich electron density closer to the nucleus. As you move away from this, you will get one node, then again the electron density increases, and then you will get one more node, and then again the electron density. So this is the graphical representation for 3s. Graphical representation for 3s orbital. So now we have 2p. We'll move the next one, that is 2p orbital. Now we have the 2p orbital. So 2p orbital, we'll try to draw this here. So the 2p orbital, this is your radial wave function. This is r. For the 2p orbital. So if we draw this, we get a plot like this. So this is the graphical representation of radial wave function with respect to distance in case of the 2p orbital. यहाँ पे आप क्या देख सकते हैं, when you move away from the nucleus, It is very interesting. S orbitals में क्या था कि electron density was initially maximum at the point number initial point, that is closer to the nucleus. At the moment you move away from the nucleus, electron density was decreasing. यहाँ पे the moment you move away from the nucleus, electron density is increasing maximum, and then decreasing. So very interesting. That means if you plot this mathematically, so you will end up with the shape of the orbital that is like this. ये ड्रा किया जाता है, मैं वो इक्वेशंस डिस्कस नहीं कर रहा हूँ. So in order to see this, you see if you move away from the nucleus, electron density is maximum. So if you move away from the nucleus, you see ये region आ रहा है, it's a maximum electron density. And then after this there is zero electron density. At the nucleus, you see अब lobes को देख लीजिए, दोनों lobes को, dimensions of lobes, at this point there is no electron density. So that means in case of what you call as the 2p orbital, if you plot radial wave function with respect to the distance, so what you will see, you have maximum electron density at the, if you move away from the nucleus, the electron density goes in increasing and then decreases. So it goes in increasing and then decreasing. So that means we have this type of a shape. Now why it is that? Because in 2p orbital our principal quantum number is 2, n is 2, but now p has some value, that is 1, because we know that this azimuthal quantum number for p orbital, that is L value, is 1. So if you plot n minus L minus 1, what is your n? That is 2 minus 1 minus 1. What is that? 0. So that means the number of nodes is 0. So that's why we don't have any node here. So that means in case of 2p orbital, we don't have any node, and this is how the electron density varies. Now, there is some more thing we need to discuss, but I will check one. We'll go to, this is 2p. Now we have 3p orbital and 3d. So we have 3p and 3d orbital left. So 3p orbital, we'll plot 3p orbital here. So we have 3p and 3d now left. 3p and 3d left now. 3p and 3d. So 3p, let's take this 3p. So this is your radial wave function on this side, and this is your distance from this side. So 3p orbital will get like this is how the graphically you can show it. That means if you move away from the nucleus, the electron density increases, reaches the maximum, and then at some point there is no electron density. That's we have a node here, and then we have high electron density again. So that means this orbital will look like this. मैं यहाँ पे दिखा रहा हूँ, इतनी representation अच्छी नहीं मेरी, but now this is the p orbital I am showing here. अब यहाँ देख सकते हो कि this is these are the lobes of the p orbital. They are high electron density. यहाँ पे जो gap में दिखा रहा हूँ, this one. So you can see this gap here again is focusing the camera. यहाँ पे I'm showing this vacant area. So this is basically that node here, this node, and then there's again the electron density here. So this is your this is your node, this in the p orbital. So that means let us calculate the number of nodes, that is n minus L minus 1. N is 3, L is 1, so that is 3 minus 2, that is 1 node. So we have 1 node here. Fine. So now, so in the same case, we have one more orbital left, that is the 3d orbital. Now 3d, let us plot the graph. So 3d orbital, this is your radial wave function. This is your distance. So So you got 3D orbital, you have this is the graphical representation. That is, you have maximum electron density comes when you move away from the nucleus. Then you will get a maximum here, a maximum point, and then the electron density again decreases. So this is how, that means closer to the nucleus we have 0 electron density. So let's calculate the number of nodes, n minus L minus 1. N for 3D, that is 3. For d orbital, L value is 2. So 3 minus 3, that is 0. That means no node. But that's why we don't have any node here. And if you plot this d orbital, and we know that the shape of the d orbital looks like this. इनको हम आगे भी discuss करेंगे. Let us say our d orbital is dxy. So this is how the d orbital looks like if it is xy. आप clearly देख सकते हैं, this is the nucleus. और हम जानते हैं न्यूक्लियस में इलेक्ट्रॉन डेंसिटी नहीं होती है, it's a positive part, and then you can see here there's no node at all. So this is your 3D orbital where we don't have any node. So this is basically your syllabus. That's the graphical representation of wave function. That is your radial wave function. So this was the graphical representation of your radial wave function as per the syllabus. So what I have tried is I have try to make it very very simple rather than going very very complex. अब इसमें एक question यहाँ पे आता है, this I want to add here. So what we have done so far is that in case of these orbitals, that's 1s, 2s, 2p, 3s, 3p, 3d, we see that there is a concept of node coming, that is a region around the nucleus where the electron density is 0 present. So the nodes vary as per the number of orbitals. So we can calculate this by the formula n minus L minus 1, the number of nodes. So these are called basically the spherical nodes. That's the regions around the nucleus where there's the electron density is 0. But in case of this p orbitals and d orbitals, this one, this is not called node. यहाँ पे हमने इसको discuss नहीं किया था. इस तरह से यहाँ पे I told this is called the node, but this I didn't discuss because there is no electron density here. This is likely in case of d orbital there is no electron density here. This is basically the nucleus. लेकिन फिर भी ये जो portion है यहाँ पे electron density 0 है. This is basically called the nodal plane. This one. So in case of p and d orbital, in case of p and d orbitals, f भी होता है लेकिन वो आपके syllabus में नहीं है. There's a concept of nodal plane. Nodal plane. Or this is also called as the angular node. So this is also called the angular node or nodal plane. So this only we talk in p, d and f orbitals. ठीक? So the nodal plane or angular node is basically a plane. ठीक? It's a plane where we don't have any electron density. So nodal plane or the angular node is basically it passes through the wave function, and these nodal planes, they are always perpendicular. ठीक? So the nodal planes, they are perpendicular. For example here you have देख सकते इसमें दो nodal planes है, they are perpendicular to each other. एक ऐसे और एक perpendicular to that. So these nodal planes are basically present in p and d and f orbitals. P and d में, and the number of nodal planes is given by L value. किसी भी orbital में कितने nodal plane हैं, they are given by L.